So let's go and try to graph this problem using sinusoidal transformations. So you're given this basic graph. Y is equal to cosine of 2x 2 theta plus pi over 2 plus 1. So the first thing that we have to do is we're going to have to take a look at what the original function is when it's factored properly. So you have cosine of, pull out a 2, so you're left with theta plus pi over 4 plus 1. Now, let's go and draw the basic cosine graph. So and we're going from pi to negative pi. So here is negative pi. Here is positive pi. Here is 1 negative, and we will also have 1 positive above. So the basic graph of this thing, of the original graph for cosine, starts here and ends there and ends there, right? With exactly halfway between it going to 0. So it kind of does this and does this. Now, for this basic graph, right, we need to go and show all of the different transformations that we studied before. It's all the same. Everything that we learned in the previous unit applies here. So when we're going to use our transformations, we have to look at what's happening inside the graph. So if we start with y is equal to cosine of x, right? Then here's what's happening. Our next graph that we have to draw is y is equal to cosine of 2x. This represents a horizontal shrink of factor 1/2. So what happened is our graph got shrunk by 1/2. So this point, so the far left point goes in by 1/2, 0 stays the same, and then this point goes in by 1/2, and then we end up with something like this. So now we have a graph that looks like this. Now that we've got that basic graph, we still have to draw the rest of it, right? So the rest of the graph will look like this. So now let's go and take a look at what happens when we apply this half of our transformation. So now when we apply y is equal to cosine of 2 bracket, let's go x plus pi over 4. This means it moves left by 1/4 by pi over 4. So that means all of the points in our graph get shifted this way by 1/4 pi. So this point goes to here. So this point doesn't go there, but it kind of goes halfway. So it goes here, and then this point goes over 1/2. This point goes over 1/2. This point goes over a bit. This point goes over a bit. And this point goes over. That point goes over 1/2. And then this point goes here. So now we have our graph looking like this. So now our graph looks like that. So I'll just draw it a little better underneath. So we have our graph at pi at 2 pi, at pi and negative pi. And our graph looks like this. Right? So now our graph looks like that. So now what happens when we have this? We have y is equal to cosine of 2x plus pi over 4, and then we add 1 to it. So now all our points on our graph shift up exactly 1 unit. So now all our points are now up here. So I'll actually draw it in green. So now our points are here and here and here and here now. And this point goes all the way up here. This point goes back up to here. And then this point goes up to here. So now all our points look something like this. And we're done. So this, remember, that extra 1 is a vertical shift. Up 1. So here is a problem that I want you to take a look at. Imagine I give you the base function being y is equal to sine x, right? And now I take y is equal to sine x, and what I'm going to do is I'm going to apply all the transformations. So in order to do that, we're literally going to build a function in terms of sine of some transformation plus some vertical transformation by some factor, some horizontal transformation, and then a horizontal shift and a vertical shift. So remember, the start will tell us how much our graph is stretched up and down. So when we look into this equation, we said that it shrunk vertically by a factor of 3/4, right? So we're going to write 3 over 4 as the amplitude for our sine function. Then remember, our graph has been stretched from 0 to 2 pi to 0 to 2 to 8 pi. So that's a factor of 4. So it's horizontally stretched by a factor of 4. So basically the k value that goes inside here is not 1 over k. It's actually 1 over 4. So if we stretch by 4, then the value that goes inside our bracket is 1/4 for our horizontal stretch. Now, when we're taking a look at shifting horizontally to the right, that means we have x. Instead of plus, instead of plus, we're going to have minus pi over 2. So we're shifting to the right too. But then it never says anything about translating up or down. So our translation up or down is 0. Now, it also said it was reflected in the x-axis. So that means this value here in front of the sign is a negative, and we're done. All right, here's your homework. Page 215. Number 35, 37, 39, 45, and 46. Good luck.